Hello everyone, welcome to my channel and I hope everyone is doing good. So in today's video, we are going to talk about the GenAI use case for data engineering. So you'd be coming to know or you'd be hearing from multiple places that how GenAI is helping the developer to write the code more efficiently by using the cloud desktop, by using the Copilot. There are multiple ways by using ChatGPT or any LLM model. By using that, a developer can write the code properly. Or in the VS Code, I have seen that with the help of AI, you can integrate the Copilot in the VS Code, and that will help you to debug the problem in the code. But for the data engineers, the things are very different. Data engineers generally create the data pipeline, create the observability platform, monitoring platform, alerting platform, looking into the dimension, schema evolution. So for the data engineer, the task is very different from the developer. So we need to see that how this GenAI things or the whole GenAI process getting fit into data engineering task. For the data engineers, very less articles are there in the internet which talks about the GenAI use case. So as I am working in a GenAI, multiple GenAI use case for the data engineering task, so I have encountered multiple things, and I have also created multiple solutions around that. But there are a list of complete use case which I'll be delivering in this lecture. And so let's get started. Before starting the video, please subscribe to my channel. Just spread this channel to your friend, to your colleague who wants to transition their career in the data engineering skills, or who want to know or want to excel more into the data engineering skill and also in the GenAI. So we'll start now. So the first use case is to generate complex SQL queries from the natural language. Like there are the list of multiple tables, and you just want to get the queries. For example, you want like top 10 employee or top 10 claim process, top 10 order value. Just you can write like just create the queries for the top 10 order value, or give me the output for the top 10 order value, and also show the queries. So the system will create the SQL out of it, and also it will give you the output. So these can be achieved by using the NLP feature of the LLM. You can directly use the LLM to do that, but that should be in context with your business. I mean to say, for example, you are using Snowflake, so you will have multiple tables. So with the help of general LLM, you cannot achieve that. So you need to make the model understand what is your context, business context, what is your metadata, and then your questions can be answered. So for the Snowflake, a very good AI feature is there, Cortex AI. Now there is a Cortex code also, which will help you to write multiple things. But I'm talking about the Cortex AI. If you don't know about the Cortex AI, you want to know the general features about it, you can go to the Snowflake playlist and you will get one video on that. I already created that. So in the Cortex AI, you can create the agent. You can tell the agent which all schema you will have access, which all database you will have access, which tables you will have access. And accordingly, you can write the queries in the natural language, and the Cortex AI will generate SQL out of it. The other process can also do in the development process, like you can use the Copilot to do that. But we are talking about the data engineering task. Data engineering tasks evolve or revolve around the data. So where there is data, there only you create a data engineering task. So if you want to create these kind of solution, so I think the Snowflake Cortex AI is the best thing to do that. There are multiple things available in the market, but I'll tell just go with the Cortex AI of the Snowflake. The other very important use case is metadata generation and documentation. I will add it here one more thing, documentation, and I want to add lineage. No. Data engineering is like data pipeline is the heart of the data engineering task. So you have a data pipeline in which data, there are multiple sources, there are multiple intermediate transformation, intermediate dumping areas, and then there's a final curated layer. So in that, there are multiple tables, multiple data is interacting with each other. So there will be a metadata generation. You can use the LLM. You can create your own LLM pipeline or GenAI pipeline to have the metadata generation. You can use the other like market. You have multiple AI features are available, but they are also creating a pipeline on the top of that. Documentation, for example, you have created a metadata hub, like you have a source to target mapping. So there are a pipeline is there. You have created a source to target mapping, like how a particular column value is transformed and created. So if you have that information in a text file or anything, so with the help of any LLM or Gemini tool, you can create the documentation, technical documentation out of that source to target mapping. The other thing is lineage. Lineage means how a particular column has been generated. Like for example, there is a total sales. So total sales can will be generated from the sales, intermediate sales. The intermediate sales will be created from the multiple invoices. So this lineage, data lineage, can be created with the help of GenAI. But like there is no direct solution for the metadata generation, documentation, or the lineage, especially for the lineage. So what you can do, you can club the traditional way plus the GenAI way to create the overall solution. So for example, in the lineage part, you can create the source to target mapping from your side. And then later on, your GenAI pipeline will be used to create the more better lineage visualization or the lineage thing. One more interesting use case is like I have encountered that, but we are still working on the solution. The one more very important or very interesting use case is, now, for example, you have created some system which parses your SQL queries, your PySpark system, or any of the application in the data engine, and create the source to target or create the lineage visualization, or in a text file also source to target as an output. But not after a few days, that same application, the lineage application, encounters something, encounter a very different kind of PySpark code, or encounter a very different store procedure, which this particular application was not written for. So in that case, the GenAI agent should be intelligent enough to understand that what is this new scenario, how to tackle this new scenario, like for tackling this new scenario, what are code changes it has to do. So I mean to say, in case of new kind of things or new kind of data scenario, new kind of store process scenarios, your application or the GenAI application for your data engineering application should be intelligent enough to suggest the data engineers that where all the changes will be. At least suggestions should be there. I don't want it to go and do the changes because it's a complex process. At least it should give a list of suggestion, and then you can review it, have a multiple conversation around with your leads, with your client, and then you can go with the changes. So this is very important. Now, before moving forward, I want to say that for the data engineering task, there is no perfect way to do that, or there is not no single way to do that. Especially if you're talking about the GenAI use cases. So there are multiple scenarios, like in any of the scenarios of the data engineering task, you have to use multiple solution. You have to also go with the traditional approach. So I'm saying that for the data engineer, the traditional concept will be always there. You have to always get yourself better in the traditional basics, and then only you can use the GenAI feature on the data engineering task. Okay, so we have seen these two use cases, which is very important. The other thing which I see, like as I mentioned, for the data pipeline creation, like data engineering task, main task is creating data pipeline. So I've seen people generating data pipeline with the help of GenAI, GenAI LLM, creating a pipeline on the GenAI. So what people are doing is like they are giving the, like, this is my source, or this is my destination, this kind of transformation we need, these are the data I want, a day zero data, day zero load, day one load, I want a real time or something. So create a data pipeline architecture for that. And I have seen in multiple cases LLM is able to do that. But I'll say in most of the cases, the diagrams are created, data pipeline architecture are given by the LLM, but that is not practically relevant in your scenario. Why I'm saying it's not practically relevant, because the client has a different set of data engineering tool. Maybe they are using AWS, some of the AWS services, and some of the other traditional services. They may be using some, like for example, GCP. But your data pipeline generally goes with the perfection. If you go with the LLM, it will create a perfect pipeline. But always in the data engineering skill, when you create a data pipeline, that should be in line with what all resources are available to you. So it will give you the overall, it will give you an idea like how this architecture pipeline will be there, or how the data pipeline architecture should look. But then again, you have to use your intelligence to make it in line with the current project scenario. Now, other important use case I want to talk about is data pipeline monitoring and alerting. Like you have already created a data pipeline, and then you have to set up the monitoring process, and also alerting. For example, like a particular data pipeline, like which all jobs has been completed, that kind of report can be created automatically. If there is a job failure, it can give you the alert. Monitoring means it can monitor the performance of your system, also performance of your of the applications. It can monitor like a particular batch job, what is the quantity of data movement in each of the batch job that can be done. That monitoring analytic, there are multiple tools. There are Dynatrace, there are Splunk, there are Datadog. You can create your own custom monitoring analytic tool. If you're using AWS, you're using data pipeline on the AWS, you will have the CloudWatch. You can create your own dashboard, get the data log from the CloudWatch, and you can create multiple kinds of report. But the thing is, if there is a sudden drop in the volume, I want to say, like, if there is a something drift in the volume, data drift, we can call it a data drift. I mean to say, like, today 100 GB of data is getting processed, and suddenly in 2 3 days the volume of 100 GB has been reduced to 30 GB, 40 GB. So obviously there is a data drift. Data normal way of the data volume has changed. So for in that case, in the monitoring dashboard, you will get that report, but manually you have to go and check it every time, and then only you can will have the essence of that. So with the help of GenAI, with the help of AI feature, like Dynatrace has this, they has their own AI feature, Splunk has this own AI features, or you can write your own GenAI pipeline on top of that, and that GenAI pipeline will tell you that there is a sudden data drift, or there is sudden schema drift. For example, a table schema is changing a lot. Some of the table schema or data, the structure of the data is changing. So in that case, schema drift or unexpected null spikes, multiple records has come up null because of some upstream problems. The multiple column has been populated as null value. So these all things, if it comes in any of the batch job, this your GenAI features or GenAI things will capture this and just give the alert for that. So this is very important, and it is very difficult to implement. This looks, or when I'm talking to it, it's in very simple way. But I have worked on this case also, data monitoring with the GenAI analytic. This is really complex thing. One more important thing can be done, like multiple times you get an alert as a warning, or there are multiple job failure alert, but that doesn't need any urgency, or we don't have to go and just look into the root cause. Just you restart the job, it will work. So your GenAI agent should understand which is the urgent issue, which is not the urgent issue, in which a normal kind of failure where the rerun can work. Then your GenAI can suggest for the rerun, or if it is not very critical job, then the GenAI agent should go and take the action for the rerun. So this is important. See, all the use case of data engineering task is will be not straightforward. It will have multiple intelligence you have to use, and multiple your experience will also come into the picture. Now we'll move to the next use case. Two more use case I want to discuss. The first is the debugging and root cause analysis, and the other is data quality and validation. Debugging and root cause analysis, like if that job has failed, so what will the root cause? So in most of the cases, the job failure would have happened multiple times, so you already know the root case, and you can make the GenAI agent learn about it, or have that metadata information ready, where the GenAI can go and look into it. Like if it has already been done, then it will give you the suggestion. Or in multiple time, there are a lot of log, and log not only about the one application. There are multiple applications, multiple data flows which are interrelated to each other. So there are multiple logs which have to be scanned. So your GenAI multiple agent, multi-agent GenAI pipeline can look into multiple logs, and then each agent can like talk to each other and create a solution on top of it. So this is I have not actually worked on this use case, but this is where people are investing a lot to build up this kind of solution. The other thing is data quality and validation. This is like very essential for any experience of data engineers. So you can use LLM features to look into the data quality, validation. Like people generally create a data quality framework with the help of the rules. You put on some rules, and it will check that rules. If that data passes through that rules, then the data quality is of good quality there, and if it doesn't pass, then data quality is of not bad quality. Apart from the data quality, I can also that the program quality. If you're writing a PySpark, Python, and Python quality, there are multiple framework for Python, but still you can use the GenAI things for that. For the data quality framework, GenAI, multiple GenAI LLM with the pipeline can be built to check for the data quality in a multiple data format. For example, for the JSON, you can have a different a same pipeline can work for the data quality of JSON, also for the text file also. So this is important. So if I talk about, there are multiple others, other use case in a data engineering field, where GenAI use case directly fit into it, but these are the important use case where people are investing money, where the client are investing money, and we are getting task around it. So if you're not working on this use cases from a GenAI perspective, still you can Google, you can find more details of it. If you have any doubt, want to discuss more about it, you can ping in the, or post the comment. I'll just contact you, and directly we can have a better discussion, healthy discussion on top of it. These are the important use case. I'm saying you, I'm in this industry, this is going to be the next thing. So just look into it seriously, build a healthy community. Just talk to me about this use case if you want to learn more about it. And then you can use, like if I talk about the solution, so you can use the LLM with the agentic approach. You can use the LangGraph framework, go and learn LangGraph. I'll have some use cases on the LangGraph in I think in the coming videos. And then if you are a GCP, you can go with the Vertex AI, ADK. Learn, I mean to say, learn any of the pipeline or the framework which will help you to create the Gen AI pipeline, especially the agentic pipeline. Almost all the pipeline now support the agentic things. Rest, I think just focus on this. Nothing more for this video. If you have any doubt, please post the comment. You can contact me through LinkedIn. You can directly mail me. I'll come up with the next video of land graph. Till then, happy learning and goodbye.